Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 11 in the Broken Access Control module titled Insecure Direct Object References. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down, select access control, and then go down one more time and select lab number 11 titled Insecure Direct Object References. Alright, let's get started. This lab stores user chat logs directly on the server's file system and retrieves them using static URLs. Solve the lab by finding the password for the user Carlos and logging into their account. So the target goal over here is view the chat history for the Carlos user, and in that history we'll find his password and then we log into his account. Okay, let's access the lab. Now notice I'm using the built-in browser for Burp, and so all my requests are already going through my Burp proxy. Alright, the application loaded. It looks like it's a similar application to the one that we've been dealing with in previous labs. It does have a live chat functionality, which is new. So let's click on that. It allows us to enter a message. So let's enter a message and hit send. Now notice over here, I sent a message and it gave me a response. Even when I send another message, I don't get an entry in my proxy, which means that I think this is done client side, and that's why it's not going through my proxy. But either way, let's view the transcript and see what request it makes. So it makes a post request to download the transcript, and then from there it redirects to this URL over here. And this looks like it's a static URL because it's just a single number and then a TXT document. So if we look at that specific URL, you could see over here the chat history that we just went through. So over here I said test, and then the application responded, and then right over here, sorry, and then I said test again, and then the application responded, and so on. So the first thing I want to test for is see if there's any other chat histories that I can access. So you could see over here it's 2.txt, which means there must be a 1.txt. Hit send. And here we go, we gain access to another chat history. Now this is called an insecure direct object reference because you're able to directly access this object over here, which is 1.txt, by simply adding a reference to the object. Now, if this had proper access control, what it should do is check if the user that is assigned to this session ID has access to this specific object. And if he or she does, then it should allow access to that object. But if he or she does not have access to that object, it should prevent the user from viewing that information. But clearly, we have an insecure direct object reference vulnerability over here. So let's see the chat. It looks like it's between another person and it doesn't classify which person it is, but the person seems like they're having an issue with the account, and so the bot says, give me your password to confirm if it's correct or not. And so the user says, here you go, this is my password right over here. So let's copy that. Now this could be for any account. However, the exercise wants us to solve it for the Carlos account. And so my guess is this is for the Carlos account. In a real world pen test, you would try this password on a ton of accounts to see if it works. So let's go to my account, put in Carlos, put in the password, click login. And here we go. We get the message, congratulations, you solved the lab. Alright, so we successfully completed this exercise by exploiting this vulnerability manually. Now let's script it in Python. Alright, the first thing that we're going to do is import our libraries. So request library, the sys library, the URL lib3 library, and the beautiful soup library. So from BS4, import beautiful soup, and the regex library. Next, we're going to disable warnings. So disable warnings, and that's for exceptions. So that's for insecure request warnings. And then we're going to set our proxies configuration because we want all of our requests to be sent to Burp just in case we need to view them or debug them. So Burp is running on HTTP 127.0.0.1 on port 8080. We also want to send HTTPS traffic to that exact location. So HTTP 127.0.0.1 and port 8080. All right, this looks good. Next, we'll create our main method. So if name is equal to main, then call the main method. And we'll define that right over here. So def main, we'll say if the length of the command line arguments is not equal to 2, then print the usage instructions. And then also print the example instructions. All right, so if the user runs the program incorrectly by putting in the incorrect number of command line arguments, then we're simply printing the usage and example instructions to help the user figure out how to run the program. And then we're going to exit the program because the user ran it incorrectly. Now, let's assume the user does run it correctly. The first thing that we're going to do is create a sessions object that we'll use across requests. And then we're going to create a variable called URL and set it to the second command line argument. And then we're going to call a function called retrieve Carlos password that takes in the session object and the URL. And the return value of this function, we'll save it in a variable called Carlos password. And we'll implement this function in a bit. So let's just add a comment over here saying rest of code. So the first thing that we need to do in our script is access the live chat functionality and retrieve Carlos's password. And then the second item to do in the code is to log in as the Carlos user. So this function over here will perform the first item, which is retrieve Carlos's password. And we'll implement it right here. So def retrieve Carlos password, and again it takes in the session object and the URL. We'll create a variable called chat URL, and that would be the URL plus the path to Carlos's chat transcript, which is this one right over here. So let's copy this, and this script assumes that it'll always be 1.txt. If that changes, the script won't work. All right, next we'll perform the request, so s.get. So we're essentially performing this request, which is a get request. It doesn't take in any parameters, and then we're going to try and extract the password from the response of the request. So to perform the request, it would be s.get. It takes in the chat URL, set verify to be equal to false because we don't want to verify TLS certificates, and then proxies to be equal to proxies because we want the request to be sent through Burp. And then we're going to set the response to a variable called res. And then what we're going to do is we're going to search for the string password in res. And if we find it, we'll print found Carlos's password. But if we don't find it, we'll print could not find Carlos's password. And we'll exit the program. All right, so essentially all it'll do is perform this request over here and then search for the string password in the response. If it finds it, and it will for this specific request, then it'll print that they found Carlos's password. We're going to copy this because this is going to come in handy. So the next step over here is to parse this response over here and gain access to the password of the user. And the way that we're going to do that is using the find all function. So we're going to say Carlos password is equal to re.findAll, and we'll use a regex string over here. So this is the string that we're going to look for, and it's between this string over here and this string over here. So I'm going to say search for all the characters that are between this string and this string. Now the dot we need to escape so that it doesn't see it as a regex character, and then click save. Now we return password. And what that'll do is when the function is called, which is over here, it'll return the value of the password and save it under the variable Carlos password. So let's start off by testing that this works. So print Carlos password, and let's save that. All right, next go to terminal, new terminal, and run the program. So Python 3, access, control, lab11.py, and this likely timed out, so let's open it again. Copy the URL, paste it here, remove the trailing slash, and hit enter, and we get an error saying it cannot import beautiful soup. I likely spelled that incorrectly, and I did. There's no U over here. So let's clear and run it one more time. And I did make a mistake over here. So I'm saying find this string over here, but I'm not telling it where to find the string. So it's under res. So we're searching through the response of the request. And then over here, find all actually outputs a list of values that satisfy this condition. However, we'll only find one instance of that specific string, and that would be in the first position of the array. So let's save that. Clear, and hit run again, and we still have an error. So return Carlos password. I'm not very focused today. Let's save, clear it, and run one last time, and here we go. So you could see over here it says found Carlos's password, and we print it out. So this part of the code works. Let's remove this and then write the rest of the exploit. So after we find Carlos's password, the next step is to log in to Carlos's account to confirm that the password actually works. So to do that, we're going to say print logging into Carlos's account. And then we're going to call another function called Carlos login, which takes in the session object, the URL, and Carlos's password, which we just identified. And you could see over here that's also spelled incorrectly. All right, and so let's implement that function right now. So let's say def Carlos login, takes in the session object, the URL, and the password. Now, before we implement the code to log in, we need to understand how the application handles the login functionality. So if we go back to proxy and we search for the post request that was used to log in, you could see over here again, it's a post request. It's to the path /login, and it takes in 3 parameters: the CSRF token, the username, and the password. The password we know because we just extracted it. The username we know because we're targeting the Carlos account. However, there is a variable over here, so the CSRF token, that we don't know off the top of our head, and we need to extract it. And the way we're going to extract it is by loading the /login page a GET request. So if you look for CSRF right over here, you could see that's where it's extracted from. So the first thing that we need to do is get the CSRF token from the login page, and then we could log into the Carlos account. So let's add a comment over here saying get CSRF token from the login page. And to do that, we've got the login URL, which is equal to the URL itself plus /login. And then we have CSRF token is equal to get CSRF token, which takes in the session object and the URL. And we'll say rest of code here. So to get the CSRF token, we're going to implement a new function called getCSRFToken, and the return value will be saved over here, and then we could complete this function. All right, so let's implement that function right over here. So def getCSRFToken, again, it takes in the session object and the URL. As I mentioned earlier, it's a GET request to the login page, set verified to be false, and proxies to be equal to proxies. Next, we want to parse the response, so we're going to use Beautiful Soup to do that. So the response of the request, and we're setting the parser to html.parser. And then we're going to say CSRF is equal to soup.find, and we're looking for the CSRF token. So if we look over here, it's in an input element that has the name CSRF, and the value is under the value attribute. So under find, we're going to say look for an input element that has the name CSRF, and I want you to only output the value that is under the value attribute. And then I'm going to return my CSRF token. Okay, this looks good. Now the CSRF token is going to be returned over here, and it'll be saved in a variable called CSRF token. The next thing is to log in as the Carlos user. To do that, let's print logging in as the Carlos user. And then to perform the login request, let's look at the request over here. It's a post request. It's to the path /login, and it takes in again 3 parameters. So the CSRF token, the username, and password. Now we have all 3 parameters, which means that we could log into the account. First, let's save the parameters in a variable called data login. Set it to username is equal to Carlos. Password is equal to the password that we just extracted. So that's password, which we take from over here. And then we're going to say CSRF is equal to the CSRF token, which we also extracted from this function right over here. Next, we perform the request. So r is equal to s.post, takes in the login URL, set data to equal to data login, set verify to be equal to false, and proxies to be equal to proxies, because we want our request to be sent to burp. And then we're going to save the response in a variable called res. And to confirm that we've actually logged into the account, we're going to check if the logout string is in the response. If it is, we'll print successfully logged in as the Carlos user. Otherwise, we're going to print could not log in as the Carlos user. and we'll exit the program because our exploit failed. All right, this looks good. Let's save it and let's minimize this a little bit. So essentially, to summarize what we're doing, the first thing that we did is create the main function. If you don't run the program correctly, you'll enter this if clause. But if you do run the program correctly, it'll start off by retrieving the Carlos user password. And the way it does that is using this function over here. And the function, it essentially performs the request to view the transcript of the Carlos user, and then it parses the response to retrieve the password. From there, it returns the password, and that password is used in the function called Carlos login, where we use the password to log in as the Carlos user. Hopefully there's no errors, so let's try that. And we didn't need to open a new terminal, we could just use this one. Now chances are the application timed out, so let's open it one more time. Let's copy that, paste it, hit enter, and we do get an error. So you could see over here line number 26, and I know what the error is. This should be in single quotes. Let's save it, clear it, and run it again. And we get another error, again on line number 26. It looks like it can't find the CSRF token, so if we go to Burp and just check the request that it's performing, it does not have a CSRF token on it, and I understand why. So we must be passing the main URL and not the login URL. Here we go. So you can see over here, you need to pass in the login URL. That's where we retrieve the CSRF token from. And that's why it's really important to pass all your requests in Burp, because it'll help you debug the application if there's any errors. All right, it ran correctly. You could see over here, you got the message. Congratulations, you solved the lab. So we've successfully completed the exercise by first exploiting the vulnerability manually and then scripting it in Python. In the next couple of labs, we'll look at more complex cases of broken access control vulnerabilities.